Have you ever just played around with something like ChatGPT or used Google Translate and just wondered, how does it do that? How does it seem to actually understand what you're saying? Well, it's not magic, but it kind of feels like it. Today, we're going to pull back the curtain on the paper that started it all. Attention is all you need. We're diving deep into this single academic paper that literally changed everything for AI, and we're going to break it down in plain English.
So let's start with that big question. How does a machine really truly get from a jumble of words to something that sounds, well, human? The answer is a really, really brilliant piece of engineering. And that secret, that big answer, was dropped on the world back in 2017 by a team of researchers at Google. They published this paper with a title that was so simple, yet so bold, and it kicked off the AI explosion we're all living through right now. Okay, so to really get why this paper was such a big deal, we have to travel back in time a little bit. We need to understand the problem they were trying to solve. See, before 2017, AI language models had run into a massive, massive wall.
The best models back then were these things called recurrent neural networks, or RNNs for short. And they worked a lot like how you and I read a book, one single word at a time from start to finish. I want you to imagine trying to understand a whole movie by looking at it through a tiny little peephole, seeing just one frame at a time. That's kind of what an RNN was up against.
The paper itself has this great phrase for it. They call it the inherently sequential nature of those models. And this created two huge problems. First, it was just slow. You can't speed things up if you're forced to read everything one word after another. But the bigger problem? The models would forget. By the time an RNN got to the end of a long sentence, it had already forgotten what was at the beginning.
And this right here, this comparison, really gets to the core of it. The old way, the RNNs, was this slow, forgetful, one word at a time process. But what this paper proposed was a whole new architecture they called the transformer. It could look at all the words at the same time, instantly. This meant it was way faster, and it could finally understand the full context of what was being said.
So how on earth did they do that? How did they make an AI that could see everything at once? Well, this is the big aha moment of the paper. They came up with a mechanism that let an AI read in a totally new way. It's called self-attention. And instead of that tiny peephole, self-attention lets the model see the entire painting at once. It looks at every single word in a sentence simultaneously and figures out how each word relates to every other word. It's no longer just reading. It's understanding relationships and context across the entire sentence, all in a single glance.
This idea was so powerful, so central to their whole breakthrough, that they put it right there in the title. Attention is all you need. I mean, what a bold statement, right? They're basically saying, hey, you know those old sequential models? You can throw them out. You don't need them. All you need is this.
So this new architecture, built on this idea of self-attention, is what they called the transformer. It's the engine that powers pretty much all of the AI we use today. Let's pop the hood and take a quick look at how it works. The paper breaks it down pretty simply. First, the whole sentence gets fed in at once. Then, a part called the encoder acts like a reader. It's actually a stack of 6 layers that all work together to build a really deep understanding of the input text. Then, a part called the decoder, you can think of it as the writer, takes that understanding and starts generating the new sentence, say a translation, one word at a time, until it's done. But what really makes this whole thing sing? What's the real secret sauce? Well, the paper explains it's not just one attention mechanism looking at the sentence. It's a whole team of them working together. They call it multi-head attention. Now, the technical jargon in the paper is a bit dense, but the best way to think about it is like having a team of expert analysts all reading the same sentence at the same time. One expert is just looking at grammar. Another is tracking who's doing what to whom. A third is figuring out what it refers to from earlier in the text. The transformer uses 8 of these heads or experts all working in parallel to build this incredibly rich, multi-layered understanding of the language.
Okay, so the theory is absolutely brilliant. It sounds great on paper, but did it actually work in the real world? Well, the results weren't just good, they were paradigm shifting.
Let's look right at the data from their paper. This table shows the scores for a standard translation test. That blue score is just a measure of quality. The higher the number, the better the translation. The absolute best result anyone had ever gotten before, even by combining multiple models, was a 26.36. The transformer came in and scored a 28.4.
Now, I know what you might be thinking. A 2-point jump doesn't sound like a lot, But in this world, that is a massive leap. It's like a marathon runner suddenly smashing the world record by 5 minutes. It just wasn't supposed to happen. They didn't just inch past the old record. They blew it out of the water and set a completely new standard for what was possible.
And here's the kicker. This is my favorite part. Not only was it better, it was also way, way more efficient. According to the paper, they trained their best model in just 3.5 days, which was a tiny fraction of the time and money it took for the older models. So let's get this straight. It was better, it was faster, and it was cheaper. That is the definition of a game changer.
The impact was immediate. The very next year, OpenAI took the writer part of the transformer, the decoder, and built the first GPT model. Then, in 2019, Google took the reader part, the encoder, and built a model called BERT. From there, it was off to the races. The transformer became the fundamental building block for basically every single major AI language model we have today.
So if you take just one thing away from this whole explainer, let it be this. That deceptively simple idea of looking at the whole sentence at once is what unlocked everything. It allowed AI to process massive amounts of text in parallel, leading directly to the incredible scale and power of the AI tools that are changing our world today.
And that leaves us with one final, kind of exciting question. This one paper, this one idea, literally redefined an entire field. So it really makes you wonder. If attention was the big bang of the last era of AI, what's the next one? What's the next revolutionary idea just waiting out there to be discovered?